Assalamualaikum warahmatullahi ta'ala wabarakatuh. So, we are the group number 15. So, our topic is all about system design and layout. System overview, Bakara-Venta River irrigation. Bakara-Venta River, source of irrigation water. Brush dam and main canal infrastructure for water diversion and flow. 12 kilometers length of the main canal, 9 sectors, number of division served by the system. Zanzara's local term for irrigation association systems within the sector. So meaning, in this, the overview of the Bakara-Venta River irrigation is, the irrigation system is situated along the northern banks of the Bakara-Venta River. Water is diverted from the river using a brush dam and then flows through a main canal that extends for 12 kilometers. This system is divided into 9 distinct sectors. It's served by Zanzara, which are essentially local farmer groups or associations responsible for irrigation within their specific area. So meaning, ang system na ito is divided siya into 9 distinct sectors. And it serves by the Zanzara na kung saan siya yung essentially na local farmer groups or association na responsible for irrigation within the specific area. Water is conveyed to the fields through lateral canals connected to the main canal. So next is farm ditch density and topography. Farm ditch density varies significantly by Zanzara, 54 to 171 meters per hectare, range of farm ditch density. Topography influences the variation in ditch density. Rolling terrain characteristics of Zanzara's north of Venter town. Semi-terrace fields, how water is distributed in rolling terrain. So, in farm ditch density and topography, the density of farm ditches, the small channels that distribute water directly to the fields, varies considerably across the different Zanzaras, ranging from 54 to 171 meters per hectare. So, meaning, this density of farm is nagre-range siya into from 54 to 171 meters per hectare. This variation is largely influenced by the topography of the area. For instance, Zanzara is located north or Venter town. San Jose, Cabarroan, San Juan, Sinigpet, San Pedro, and Colibeng are characterized by rolling terrain. In these areas, more extensive water channels are needed to effectively distribute water through semi-terrace fields. Conversely, Zanzaras closer to Bacara, Santo Rosario, Nibiniv generally have lower farm ditch densities. So next is the farm ditch density by Zanzara table 25 data. So in this slide, they signifies the San Jose has a 141 meters per hectare, Cabarroan 114 meters per hectare, San Juan 86 meters per hectare, Sinigpet 86 meters per hectare, San Pedro has 171 meters per hectare, Colibing 93 meters per hectare, Surigui has 60 meters per hectare. Note, Surigui is not mentioned in the text, but is in the table. You might want to clarify this if possible. Santo Rosario has 54 meters per hectare and Nibinib 57 meters per hectare. So, in this slide, presents a specific breakdown of farm ditch density for each Zanzara within the irrigation system, as detailed in Table 25. You would present the actual data from the table here. For example, as I said a while ago, San Jose has 141 meters per hectare, Cabarroan has 114 meters per hectare, San Juan 86 meters per hectare, Sinigpet has 86 meters per hectare, San Pedro has 177 meters per hectare, Colibeng 93 meters per hectare. The surgi or the surgi has 60 meters per hectare. Note that surgi is not mentioned. So meaning ang surgi is hindi siya na-mention in the text. Pero nandun siya sa table. You might want to clarify this if possible. So, Santo Rosario has 54 meters per hectare, and the last but not the least is the Nebineb, 57 meters per hectare. So, the next slide, I have here the irrigation system layout and challenges. So, community resource management overall context. So, relatively flat terrain general topography where the system is located. Parcel to parcel flow traditional, less efficient water distribution. Farm ditches channels that lead water to individual plots. Communal gathering grounds where water often collects. Design and layout of canals key to efficient water delivery. So, service area versus water presence. Crucial distinction in water distribution. Problem exceeds demand too much water in some areas. Problem is leading service area to design doesn't accurately reflect water delivery. Problem distorted allocation water distribution is not equitable. So, in this slide, in irrigation system layout and challenges, meaning is the irrigation system operates in relatively flat area. So, meaning, nag-ooperate lamang into a flat area. So, nakafocus lang siya into flat area. Na kung saan, traditionally, na yung tubig is nagpo-flow from one parcel to the next. Modern farm ditches now lead water to individual plots, sometimes collecting in communal gathering grounds. A significant challenge lies in the design and layout of the canals, the surface area of the system, which indicates the intended reach of water, often doesn't align with the actual presence of water. This leads to issues such as excess water in some sectors and a distorted allocation of water, where some areas receive too much and others don't receive enough. So, meaning dito is nagli-lead siya ng issue na kung saan nag-i-exist yung tubig in some sectors. So, minsan is nag-allocate yung water na kung saan yung ibang area is nakaka-receive sila ng sobra-sobra. Wherein, yung iba naman is hindi nakaka-receive or tawag dito, hindi sila nakaka-gain ng tubig na tama, kumaga sapat sa kanila, despite being within the designated service area. This indicates a problem in the system design itself. So, the next one is the lateral canal network and water distribution. Main canal, primarily water channel. Lateral canals branch off the main canal to serve specific sectors. Perpendicular to main canal, general orientation, lateral canals. One sector served directly, not all lateral canals serve one sector each. Shared lateral canals, multiple sectors sharing one lateral. 1.2 kilometers length, example of lateral canals length. San Juan and Sinigpit Zinzeras sharing the lateral canal. San Pedro Zinzeras served by a branch of the San Juan Sinigpit lateral. Southern Channel serves the Sinigpit area. So, in this slide, sinasabi dito na ang main canal approximately has 1.2 kilometers long, serves as the primary conduit for water. From the main canal, the lateral canals branch out, generally running perpendicular to it. However, the system is not always straightforward, where one lateral serves one sector. Instead, some lateral canals are shared by the multiple sectors. For instance, a lateral connects both San Juan and Sinigpit, and a branch from this same lateral that serves San Pedro. This highlights a complex and sometimes indirect network of water distribution within the system, with the southern channel specifically serving the Sinigpit area. The effective reach of these laterals is crucial for determining the true service area of the irrigation system. So, I have here the map wherein makikita natin yung main canal, there, Zanzara boundary, the limits of irrigatable area. So, San Juan Zanzara divided irrigable area. San Juan Zanzara specific irrigation area, two separate areas. Service area is not contiguous. Marshy drainage area separates the two sections of San Juan. Lateral canals, how both sections are irrigated. NIA Lauog's winter system, the broader irrigation system. NIA North Main Canal, parallel to the Federation's main canal. 15 meters distance separating NIA North Main Canal from Federation Canal. Natural seeps and drains, how water from the NIA Canal contributes. Sloping land NIA area directs water to Federation fields. So, dito naman is, the overall purpose of, yung map is, the map is a visual aid to understand the system design and layout or system operation. So, this map serves as a visual aid. Kumbaga, siya yung magsiserve as a key para maintindihan yung system design, layout, or yung system operation of an irrigation system. Likely managed by Federation of Zanzaras or local irrigation associations. It illustrates the main canals, lateral canals, and the boundaries of different Zanzaras, showing how water from the river reaches the irrigable land. So, makikita nyo na may mapa dito. So, ang mapa is, siya yung nagsiserve as an KRD visual aid. So, dito is, i-illustrate dito yung main canals, yung lateral canals, and the boundaries of the different Zanzaras, na kung saan siya yung nagpapakita kung paano yung tubig galing sa river reaches into the irrigable land. So, southern lateral branches and San Pedro supply. Third lateral branch originates from the main canal, heading south, split into two canals for your distribution. San Juan Field, smaller section, one area served by this branch. Zanzara, Cabaroan, another area served by this branch. The main canal between San Jose and Cabaroan directs water to San Pedro. Lateral to San Pedro Fields connects to the main canal, marshy area, heavy cement lined. As you can see, the cement line or the heavy cement line. Located along most of its length are the San Pedro lateral. Long concrete flume converted from a poorly drained area, describing San Pedro's lateral. So, the map identifies several Zanzaras indicating the specific areas they cover. So, the first one is the San Jose, followed by the Cabaraan, San Juan, Sinigpet, San Pedro, Colibeng, Surgi, Santa Rosario, Nibineb. So, these Zanzaras are distributed across the irrigable area with their boundaries clearly marked. So, Colibeng, Colibeng Zanzara's water source and main canal features. So, Zanzara Colibeng specific irrigation area. Indirect water topping, how Colibeng receive waters. Large channel scarce source of water for Colibeng. Falls between two San Juan sections, location of the channel scar. Maintaining canal or the Colibeng. Travels through San Juan Fields, 1 kilometer length of Colibeng's canal. Small brush dam diverts water to a narrow basin. Main canal near San Jose. As you can see, mas malapit siya into San Jose yung main canal. Moves westward away from San Jose Fields. Edge of a hill, location of the main canal section. Rubble masonry construction, part of the main canal's construction. Cement lined, another construction method for the main canal. So as you can see, the cement line is siya yung another construction na method ng main canal. So reduce losses, purpose of cement lining, slippage and percolation types of water losses reduce. So, paano nga ba yung system nag-works or how the system works as depicted? So, water is diverted from the Bacara-Vinta River at the brush dam into the main canal. So, the main canal then carries water to various points where laterals branch off. These laterals convey water into specific areas managed by individuals, zanzara. Within each zanzara boundary, the farmers or the association manage the final distribution of water to their fields. So meaning, the farmers or the association, sila na yung nagmamanage ng final distribution ng tubig sa kanilang kanya-kanyang fields, likely through smaller ditches not shown on this scale. So, the map shows how some zanzaras are directly connected to the main canal. So, makikita nyo naman sa mapa, as you can see, it shows kung paano nga ba yung some zanzaras is nakadirect siya connected into the main canal. So, while others receive water via series of laterals, sometimes shared as discussed in previous text description. For instance, San Juan and Sinigpet are close to the main canal, and San Pedro is served further downstream or through a branch. In summary, this map provides a clear visual representation of the physical infrastructure of the irrigation system, demonstrating the layout of the main and lateral canals and how they serve the various zanzara communities, all drawing water from the Bacara-Vinta River. So, I think that's all. Thank you so much. Shukran and wassalam.